Hi, I'm DJ Ware. Today on the CyberGizmo, I thought I would try to continue on with the benchmarks that I had started with Gluster and looking at trying to compare the Odroid HC4 with the existing systems that I use, which is the Odroid HC1 and Odroid HC2, thinking that the newer hardware should be a good replacement. And so let's find out if that's really true or not right after this. So the basis of this test is to take a look at the Odroid HC4. So I finally got enough of them in that I can actually compare them with my existing system and see how well they stack up under load. I did some initial testing with it with an SSD, and the tests with the SSD seem to be fine, but I need to redo them. There's been some updates to the kernel since I started this. And let's find out what really is going on here. So what are the two machines? So the Odroid HC2 is an older, really old. This thing is based on a Samsung, basically a Samsung 5 phone. So yeah, it is a Cortex A15. They claim 2 gigahertz. It's not. It's actually a 1.4 gigahertz on 4 of the cores and 1.1 gigahertz on the other 4. It's a fast and it has a more powerful CPU set of CPUs, and then 4 that run in diminished mode in order to save power. But you get a total of it is a Core A7, and you get a total of 8 cores together. So it's pretty powerful, but it is old. It only has 2 gigabytes of memory, and that is LPDDR3. And there is a SATA 3 port for either 3.5 or 2.5-inch hard drives and SSD drives. However, it goes through a USB bridge. So there's a little bit of performance decrease there, but when you're dealing with hard drives, USB 3 is not all that slow, and you can absorb most of it. Now you get into SSDs and you might have a problem, but with spinning drives, you won't use those up. It has a gigabit Ethernet port and USB 2 port, which is used for attaching keyboards and USB sticks. It has a UHS-1 micro SD card slot for the boot media, and it does not have any provisions for eMMC, of course, because the actual board is mounted directly onto this, onto the chassis here, this serves as both the support for the hard drive as well as the heatsink. So there is no fan; it is fanless. The Odroid HC4, in comparison, is an AM Logic S905 X2 processor. That is a 1.8 gigahertz machine, which is a quad-core Cortex A55. So it's a more modern processor, which doesn't say it a whole lot. But it is a ARM 8.3 version of the code base. So it is later in its design than the A7 on the HC2. It has 4 gigabytes of LPDDR4 RAM, has 2 SATA ports, but they don't identify if it's SATA 1, SATA 2, or SATA 3. So there might be some issues here that we just don't know about. I tried to go through the hardware info. I'm not finding out anything about it, and so I'm going to use my benchmarks as a basis to find out. There is a Realtek gigabit Ethernet port, and it also has a USB 2.0 host port, which is, of course, used for either USB sticks, or you can use it for keyboards, whatever you might need there. If you need to attach both the keyboard and a mouse to that port, of course, you will need a bridge of some sort in order to provide you with 2 more USB ports, because there's only 1 on the machine. It has a micro SD slot, UHS-1. It's an SDR104. So any of the, I think SanDisk Industrials are what they recommend. I'm using a SanDisk Ultra in it right now, which could be contributing to some of the things that I'm seeing with this. But yeah, anyway, let's take a look at the benchmark. So the first thing I did was, as I always do, is to go and do a Iperf 3 test on the machines once I get them up and configured. There are some problems on ARM, especially with Ubuntu and the later releases with Odroid. Sometimes the Ethernet port will drop back to 100 megabit, and it's random. And I've noticed that usually it's a poor cable, so if I replace the cable, it usually takes care of it. But yeah, it's very sensitive to that, and it will definitely drop back in a hurry on 100 megabits. So I always run an Iperf 3 test first on all 3 machines and make sure that they are all indeed running at 1 gigabit before I do anything with Gluster. And so once I got all that evened out and then took care of that. By the way, the HC2 has a similar problem, and it always has. So yeah, the first test I did was direct drive. So this is actually on the machine using the drive directly and running my I/O zone test in order to do this. And so yeah, I'm only going to show you partial results. I just want to see the reads and the writes for the drive. I'm not running a database or anything. This is just going to be Gluster, which is going to be doing forward reads and forward writes a lot. So basically, the tests here are a raw read at the bottom, a F read in the middle, and a P read at the top. The P read, of course, is a buffered read. The F read is a normal Linux call from C, and then a read would be a raw read, which Gluster sometimes uses, but mostly it's just F read. Gluster tries to keep things normalized for the operating system, so they don't try to do a lot of tricks like Ceph does, and some of the other some of the other scalable systems. So, but one of the things here that's kind of it's kind of standing out is the F read. The HC4, now I still have a problem with this Worker 1 thing, but if you look at Worker 1, it starts out at about 2,000. This is in megabits per second. So yeah, that goes up pretty good, and then yeah, it goes up nicely as we scale up the workload. Of course, we're adding additional users on top and running the same load simultaneously. So we're trying to scale up and see how well the drive stresses, and it does quite well. It gets out to just about buffer and channel speed. So the P read is quite a bit of difference, and it's kind of puzzling to me that the HC4 doesn't do as well. It definitely, it kind of has this, I saw this sawback before, I've seen it before. I know these are really kind of small, but I wanted to make sure that was in here. But yeah, you can see the sawback here as it goes from, this is a single user, and it drops down when I hit 2, that drops down a little bit more at 3, and then it comes back up at 4, and it comes back up a little bit at 5. So yeah, I've seen this before, but usually the way my systems react is they'll peak and then they kind of drop back as the load increases, and that's, you shouldn't see this kind of I'm coming back to life again at a high load. But nonetheless, that may indicate there are some external problems. In other words, they're not I/O related. There's something else going on here. So HC2 here it ramps up and then it ramps down. And here too, again, this might be tied. It's pretty close. This one starts out high on the HC4 starts out pretty good, and then it kind of drops back, and then we see this it bumps up at 3, goes down at 4, and bumps back up at 5 again. So that's kind of weird. So on the right side, it kind of behaves more like an expected. On the initial write, we get the best performance, of course, with a single user, and it's only about 200 megabits a second. So, and then it drops back really fast. The HC2 kind of goes up. I think it's around 310 or so, and then it kind of falls back. So it ramps up to around this is first, second, and third, and then it drops back. The P write, oh yeah, we see almost an identical on the HC2 that it kind of goes up and then it caps off, and then on the HC4 we see just kind of a steady decline. as the load builds. F-write on the HC4 does quite well, except, it's really spiking up here. So this is pretty fast for that drive. That'd be 1.4 megabytes per second. That's a little unbelievable. That's a little, that's probably cached. I had caching turned off and it probably snuck it back in there. Sometimes the drivers do that, so it is a little high. But anyway, then it kind of drops off again, and the HC2 kind of stays steady and then kind of falls back kind of nice and gracefully. We'll talk about this at the end, what might be going on here, but there's some real weirdness definitely going on. Running the same, building the Gluster cluster out. Now the test here is just 3 drives on both sides. So it's basically just, it has 3 drives and it has it's 3 replicas. So you only have the size of 1 drive for these. P reads over on the HC4, it kind of scales up and then it drops back and it comes back up again. You have this odd behavior. HC2 kind of goes up to where it maxes out at the 4th user and then it starts to fall off again. I don't know what would happen if I scaled this up. But Gluster doesn't use a lot of memory and it doesn't use a lot of processor. But the processor utilization on the HC4 was higher than the HC2. That isn't saying a lot because this one has double the processors. It has 8. They don't run as fast, but it does have 8 processors versus the 4 on the HC4. The F read goes up and then it starts to fall back. This would be, if I saw any kind of load, this is kind of be what I would kind of expect to see it. It should climb, hit some cap, and then start to fall off as you try to soak it with additional load once you peaked. The HC2, it just keeps right on going up, and it doesn't perform as well at 4 users, but it does perform a lot better at 5. They're almost evenly matched here, and then HC2 is a little slower out of the gate than the HC4. So raw reads, we see it on the HC4, this kind of weird behavior that it goes through again, whereas the HC2 kind of behaves more in what I would kind of expect, ramps up nicely and then starts to fall off. This, And then the initial writes on Gluster, we see that HC4 starts out pretty fast, and then as the load builds, it kind of drops off. Whereas the HC2 just kind of, okay, I'm fine with this load. This is fine. Just keep throwing at me. I'm good. It doesn't really fall off as much as the HC4 does. The P write, which would be, the buffered write again. So we see the same kind of thing, and then we have this weirdness again. Whereas on the HC2, it's more flat, it kind of drops down and comes back up. It also has this bow in it as well. So, don't know why it does that. I would have to dig into and really find out trace it and find out what in the world is going on here. Clearly, it's more magnified on the HC4 than it is over here. HC4 performance on F-writes, pretty good. I'm not sure about what happened here. That's well beyond the drive's capability, but the HC2, they're pretty flat. So there's just some weird things happening with the HC4. So I guess let me tell you what my conclusions are here. Because of the hardware, I wasn't able to use the exact same versions of the Linux kernel and the utilities. That's pretty typical. With ARM, you have to have the kernel has to match the sock. It has to match both the hardware that's on the sock and all the system on a chip. And it also has to match what is in the kernel. So you have to have, sometimes they have to hand write some of that stuff in. And so when they release a kernel, it's going to be pretty specific to that sock. So I can't take the HC2 code and just move it over to the HC4 and have it run. It won't work. So that's always a problem when you're migrating from one particular version of a board to another. So both the HC4 and HC2 are running Ubuntu 20.04.1 LTS, but the HC4 is running a newer kernel. It's running 5.10.0, and it is an ARM64. HC2 is running a Linux kernel 5477-217. That's an ARM7, so it's a 32-bit operating system. So my hard drives are in use, so I can't just I can't take out the drives out of the existing Gluster. I can test them on the Gluster, but I can't just rip them out and put them over on the HC4, so I couldn't do that. So I had to use a Western Digital. It's the only spare I have. The spare drives I have is a Western Digital 2.5-inch, 1 terabyte black. Typically, the 2.5-inch drives, they'll perform pretty good up to a point, and then they will trail off very quickly. They just don't have quite the electronics in them to handle loads, but they do have one thing that the 3.5 drives don't have, and that is a lighter mass and a lot less distance to move the heads. So the HC2 is using the Toshiba performance drives. Those are 3.5-inch and they're 6 terabyte. So what's my next steps here? So obviously there's some things that are just plain weird going on. So I'm going to declare that this test is invalid because there's just too many things in it that I wouldn't have expected to see this much variance. I know that everything doesn't line up, but I wouldn't expect to see huge variances like this. So that indicates that there is a difference in either the operating system, the drivers on the operating system, or the hardware itself. So the only thing I can do is try to normalize things as best I can, which is what I should have done to start with, but I didn't want to tear down a production system just to do a benchmark test. So I was trying to cheat and it's not going to work. So yeah, I need to use the same drives in both systems so that I'm making sure that things are running. One thing that I am a little concerned about, that the specs for the HC2 clearly say SATA 3 and a USB bridge. There's no question about how the architecture of that particular machine works. HC4 just says SATA. Is it SATA 1? Is it SATA 3? I don't know. I don't know what it is. I looked through hardware info. I ran it and I literally just read through it. I don't see any indication that it's SATA 1. I don't see any indication that it's SATA 3. But yeah, but the tests seem to show that it does have the performance bands of a SATA 3. But I'm not quite sure on what the architecture is, and the Odroid people, they don't really tell you. So I don't know if there's something going on there in the design. I'm going to have to go onto the forums and ask some questions and see if I can get some answers. So, and the other problem I'm seeing on the HC4 is I'm seeing a lot of error messages in the syslogs on the HC4 that are related to Gluster. And they're talking about, and in there, I have found some information from some of the hardware devs and the Linux kernel devs that there's a number of issues with System D on 5.10 that are throwing these spurious messages out. But I wonder if there's a B and that it might be causing performance. Anytime you hit the log on Linux, you are definitely slowing things down, because if it's soaking the syslog with a bunch of error messages, it will impact performance. So that's why the first thing that you do in a production set before you move out of test is you turn your logging down to the minimum, because that will affect performance, and maybe that's what's going on here. Maybe as the load goes up, those error messages are increasing. So I need to check that and find out what's going on with it, and then dial them back a little. So yeah, according to the devs, though, they say that it's the information, or the error messages that are listed in syslog are actually informational. And I'm like, well, then why aren't they classified as informational? They're error logs. They're showing up as errors. So yeah, they're saying it's safe to ignore, but I'm not buying it. I mean, I'm sure whoever wrote that code knows the difference between informational debug and error. So I would think so. Anyway, I'm thinking there's something going on here with that. So anyway, that's all I had for today. It's been an interesting experience, and yes, you do run into these things with ARM, especially when you're out of the box with something fairly new. I mean, the HC4 hasn't been out all that long. I went through some of these teething issues with the HC2 and the XU4. XU4, HC1, HC2, all the same processor. So, yeah, I went through some of these teething issues with them. It wasn't too bad on the HC1 and HC2, but the XU4 definitely had some teething issues, and it looks like the HC4 does too. So that's all I had for you today. I didn't get as far with this as I really expected to get, and I wanted to put this video out because occasionally when you're running benchmarks, you run into stuff that just doesn't make sense. It isn't reacting normally. Normally, system loads when you have a good performing system that's free of bugs, normally it will kind of flow up and then it'll reach a peak, and then it's like a bell curve. It'll start to slope off the other way. You don't expect this. When you start seeing seesaws, there's something else going on. There's something else affecting the performance. It has nothing, and that will invalidate your benchmark. And I don't know if a lot of people spend a lot of time doing benchmarks for YouTube or not. I haven't really spent much time sitting down and really explaining it to people, but I'm not looking for a particular result, but I would like to see it behave normally, and it is not behaving normally. So that indicates there is something impacting my results, and so I can't accept those results, and that's the point of the video. Hope you enjoyed this today. Please like and subscribe. Hope to see you all again real soon. Bye for now.